This is part one of two videos where we're going over the problems that you were asked to do on the practice quiz for chapter 2. So the first question that you were given on the practice quiz was that you were given this Venn diagram, and you were asked to use it to determine whether the statements are equal for all sets P and Q. So you're given, this Venn diagram, U of course being the universal, P representing everything in this set P, everything in Q. You can see 1 is in P only, 3 is in Q only, 2 is in their overlap, and Roman numeral 4 is on the outside. You were asked if these two were equivalent statements. Well, I mean, there's a couple ways to go about doing this. I mean, one's a shortcut if you recognize that this is actually one of De Morgan's laws, but they kind of go through like a simple proof of De Morgan's law for sets. U is the set of 1 through 4, so all these are in the universal set. P is 1 and 2, Q is 2 and 3. And so when I look at doing not P and not Q, so I define what those P and Q would be just 2. You see their overlap. Which means if I do not P or Q, that means anything but 2. So that'd be 1, 3, and 4. Now when I look, so I did the right-hand statement first because I could, see automatically what P and Q was and realize, okay, well, basically as long as it's not in that set, it's a member of this set. Now I have to look at the two individual statements, not P and not Q. Well, if P is 1 and 2, that means that not P would be 3 and 4. Those are the things that are not in P. And if Q is 2 and 3, then not Q would be 1 and 4. And so if I do a union of these two, I'm going to combine, the 1, the 4, and the 3 together, and I get 1, 3, and 4, which is the same thing as this statement up here. So that's a proof that they are logically equivalent. But as I said, De Morgan's law says that if I do, the negation or the complement of P and Q, then that is equivalent to not P or not Q as well. So in this kind of instance, if you want to show the sets and kind of show how you came up with the answer, that's good. If not, if you recognize it is one of De Morgan's laws, by all means, state it and make sure that you are getting it right. Either one would be acceptable. Question number 2, you're given that the universal set is A through K. I don't think there's any gaps there. Sometimes I do have it. Set A is the letters C, D, F, G, I, and J. B is the set C, E, G, I, and J. And C is A, C, D, F, and H. They want you to do the intersection of A and C. Now, the intersection of A and C is, I look at these two sets, I want those letters that are in both A and C, and only those that are in both, not one or the other or both. They have to both be in A and C. So when I look at this, A doesn't. Well, so I start to set. A doesn't. It's not in there. It's not in set A. C is in both sets. So C, same with D and F, they would work. When I look at G here, G is in A but not in C. H is in C but not in A. I and J are in A but not in C. So C, D, and F are the only ones that are in both sets. The other ones, as I mentioned, don't work. So this is the final answer that you would type in for this. For question number 3, you were given the universal set in your list of fruit here, and set A is made up of bananas, apples, pears, and lemons. B is made up of pears, apples, oranges, and grapes. And C is pear, kiwi, lemon, and grape. And you were asked to match the fruit with the region it comes from. Keeping in mind that, it is possible to have more than one in each region, or basically have, yeah, I mean, so each one of these fruits, you're either going to say it's region. It can only be in one region, but any one of these regions could be used more than once. It is possible. So looking at the information here, before I started trying to make the matches over here, I'm going to, kind of summarize what goes on over here. So when I look at the first one, banana, I see bananas in the universal set, so it's in this overall box. It's in set A, but you notice it's not in set B or C. So it has to be in the part of A that doesn't overlap with B or C. So it has to be in this region right here. So bananas would be over in this region here. Apples is the next one. Apple appears in the universal set, of course. It appears in set A, and it appears in set B. It does not appear in set C. So here's where A and B overlap each other, but here's where C is also overlapping. So I want to be in this overlapping region here, but I don't want to be in this region here. So that means that apples would end up being in this region right here, or region 2. Kiwi is next. If you look at kiwi, kiwi is not in set A, it's not in set B, it's only in set C. So in set C only, it means that it's not going to be in any of these regions here because these are going to be in A or B or even both. So kiwi would end up being down there. Pear comes next from the universal set. And you notice that pears are in A, they're in B, and they're in C. So they would be in this overlapping region where I have all 3 of them. So that's where pears would go. Lime. Lime is in the universal set. But notice if I go through, lime is not in A, it's not in B, it's not in C. So lime would go on the outside of the circles. Orange. Orange is not in A. It's in B. It's not in C. So it's only in B. So it's in B, this circle here, but not in any region that would be also considered an A or C. So orange would be here. Lemons. Lemon appears in A. It does not appear in B. It does appear in C. So it's in A and C, so this overlapping region here, but it's not in B. So it can't be the part of this, so lemon would be over here. And the last one, grape. Grape is in the universal set, but grape is in B. There's something else left in A that's been mentioned here, so we know that grape is not in A. It's in B and C. So it has to be this overlapping area here that doesn't actually get into the circle A, so grape would be here. So based off of this, I can just simply make the matches. Kiwi is in region 7, and so forth and so on. You can see the regions on the Venn diagram, and I just translated them over to this statement here. In question 4, you were given the Venn diagram as shown there, and you were asked which of the following would be elements in the set of A union B. So to be in A union B, I had to be in either circle. So that means anything within this orange region. Now this is a little darker because it's overlapping, but it's still orange. So any of the letters that are in anything that's been colored orange now is going to be over here. So basically everything but these 3 letters, Q, Y, and N, is going to be chosen here. When I look at the set A minus B, now this is set subtraction. In set subtraction, this is basically being read as A but not B. Essentially, and as also was discussed in the lessons, this statement is logically equivalent to basically saying this here. So I'm looking for things that are in A, so I'm over here, but I want to get rid of anything that does not appear. I want to get rid of anything that does appear in B. So my shaded region, the region I'm looking at is this part right here, part that's in A, but none of it going into B. So B, C, X, and T are the letters that are in that set, defined by A minus B. In question 6 and 7, you had the same setup. The universal set were all natural numbers less than 16. A was all natural numbers that are less than 16 and are even. B is all of the natural numbers that are less than 16 and are odd. Oh, I went back there. There we go. So there's your definitions. And I just wrote out what those sets would be. Because sometimes it's good to see what those numbers actually are, even though writing out U is a little bit on the bigger side, but there you go. And the first question, 6, you're asked for the intersection of A and B. Well, as I look at that, and just by, I mean, and you wouldn't even necessarily have to make the list to verify it, but if A is even and B is odd, there are no numbers that are both even and odd. It's impossible. So I would not expect to find a number that's considered both even and odd, because I know one doesn't exist. So, it's not going to be the combination of all of them, because, I mean, these are numbers that are in one of the set or the other, but it's not in both. The intersection is not going to be A or B. It's going to be the empty set. There's no intersection between these two sets. They would be disjoint. On the same token, since, A is all the even numbers from this group, B is all the odd numbers from this group, and numbers have to be odd or even, or integers, I should say, or natural numbers for that matter in this case, then, I would know that, since these two together make up the universal set. So if I do their union, which means I'm looking for those that are at least in one of the sets, well, that's going to give me essentially this universal set again. So that is the union. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.